Hey guys, in this video I'm going to show you how to find the side lengths of triangles by using trigonometric ratios, where your ratios are these three, where we've got sine theta is equal to the opposite divided by hypotenuse, cos theta is equal to adjacent over hypotenuse, tan theta is opposite over adjacent, where the hypotenuse, the opposite, and adjacent are three different sides of your triangle, all in relation to the angle that we're using or that we could be interested in. So for example, if I have a triangle here, if this is the angle that you're given, or if it was an angle that you were trying to find, when we label our triangle, the hypotenuse is always the longest side. So that's this side here, and it's the side that's never touching the right angle. So that's probably the easiest one to write out. The opposite is the side of your triangle that isn't touching the angle that we're looking at. And the adjacent is just your third side, which is not the hypotenuse, but it's the other side that ends up making this angle that we're looking at. So they're the three ratios that you're going to need to know. A couple of things that you need to make sure you do is when you're using your calculator, you're going to make sure your calculator is in degrees mode rather than radians, otherwise you're going to get some funny answers. But for the purpose of this video, we're just going to be using degrees all the time. So just doing a couple of examples. This is just really a classic example. So when you're trying to find a side length, usually you're given an angle. You'll be given one other side length and you're trying to find a different one. So when you're doing these, first thing you want to do is label all the sides of your triangle so you know which ratio you want to use. So this is our angle that we're looking at here. Our hypotenuse is the side that is the longest, but it's also the one that is the opposite to the right angle. So this guy here is our hypotenuse. And this side length here, it's touching our angle, so that one is our adjacent. So the rule that we're going to be using on this one's the opposite as well, so we'll throw that in. So we're not interested in the opposite angle in this, the opposite side in this case. We're using the adjacent and the hypotenuse. So the ratio that we could use is the cos one, because that is the only one that has the adjacent and the hypotenuse. So first thing we do is we write out the rule. So we've got cos theta is equal to adjacent divided by hypotenuse. And basically all we do then is we just fill in all the variables that we know. So our angle is 30 degrees, so it's cos 30 is equal to our adjacent, which was x, divided by the hypotenuse, which was 13. Now even though this looks confusing, if you throw this in your calculator, just as cos 30, it's just a value. So the number we get is 0.866. But just in terms of rounding, what we're going to do is we're going to keep this cos 30 and pretend it's all just one number, because it is all one number. But if we convert this to a number straight away, what happens is we'll end up rounding it here, and then once we multiply it by 13, we'll round again. So just to keep the rounding down, we're not going to put this into the calculator until the very final step. So all I need to do now is I just need to rearrange to get this x by itself. So I'm going to multiply this side by 13. So I'm going to have 13 cos 30s will equal x, and then I'm just going to type this into my calculator just as it is to get the final answer. So it's going to be 13 cos 30, which gives us an answer of 11.26 if I round it. So for all these questions, you're going to go through the same process. You label the sides of your triangle. You need to decide on which ratio you're going to use, whether it's the cos, sine, or tan. You just need to fill in the variables, and you're just going to need to plug through a little bit of algebra just to get to your final answer. So another example, again, we've got a right angle triangle. Our angle's over here, so let's label the sides. This side is the hypotenuse because it's opposite the right angle. This side's not touching the angle that we're talking about, so this guy is the opposite, and the other side is the adjacent. So the only two side lengths that we're interested in this case is your opposite and your adjacent, because we're not worried about the hypotenuse. So the ratio that has the adjacent and the opposite is the tan ratio. So we'll start off with tan theta equals opposite over adjacent. Then we just need to plug in all our values. So our angle was 45, so it's tan 45 equals the opposite, which was x, divided by the adjacent, which was 5. And then all we need to do is get the x by itself, so we just need to multiply this side by 5. So we've got 5 tan 45 is equal to x, and then we just need to throw this in the calculator to get the final answer. So 5, 10, 45, it's equal to 5. And that's our solution. Now sometimes you'll end up having the variable on the bottom. So we'll do an example of that. This will be the last one. So for this one, we've got an angle up here. We'll label the sides first. So we've got the hypotenuse. Down here we have the opposite. Over here we have the adjacent. So what we need to do is decide on what ratio it is that we're using. So for this one, we've got the adjacent and the opposite again. So we're going to be using the tan ratio. So we've got tan theta equals opposite divided by adjacent. We just need to throw all the values in. So 28 is our angle, so it'll be tan 28 is equal to the opposite, which was 32, divided by the variable, which was x. So because our variable's down here, what we need to do is multiply this side by x first, because you always need to get rid of the value on the bottom of the fraction. So if I multiply this side by x, I'll get x tan 28 equals 32. And then what I need to do is get x by itself, so I need to divide 32 by tan 28. I'll end up getting x equals 32 divided by tan 28. And then what I'll do is I'll just throw this into the calculator, and that'll give us our final solution. So it'll be 32 divided by tan 28, and the answer that we get is 60.18 with rounding units. Thanks for watching. Catch you next time.